Number A, the set of singularities occur when the function is not analytic. Okay, by Lindelof theorem, it states that the set of singularities of a meromorphic function in a given region is at most countable. Okay, so I repeat again. It states that the set of singularities of a meromorphic function, the function has to be meromorphic, in a given region is at most countable. However, a general complex valued function which is not necessarily meromorphic can have an uncountable set of singularities. So this is in any book you can see. Lindelof theorem states that the set of singularities of a meromorphic function in a given region is at most countable. However, a general complex valued function not necessarily meromorphic can have an uncountable, this is important, set of singularities. Now suppose let us consider a function fz equals to summation x belongs to s 1 by z minus x, and suppose our S is the Cantor set. S is our Cantor set. Okay, then we can say this is uncountable. So consider a function that has singularities at all points of the Cantor set on C. Cantor set is uncountable, so the singularities form an uncountable set. So option A will be our true option. Okay. So option A is true. So set of singularities of a complex values function can be uncountable. This will be our true option. Now B, C, D will be false. So let us see how B, C, D is false. So see number B, limit z approaches 0 e minus 1 by z square exists. So this is not right because this is equals to infinity. Okay. So see here, option number B, limit z approaches 0, this one, e to the power minus 1 by z square approaches infinity. So this option B is our false option. Now option number C, the domain of an analytic function is always open because analytic functions are defined on open sets when they are holomorphic. Therefore a function can be analytic on an open subset of C, but if a set is not open, if a subset is not open, see this, if a subset is not open, it cannot be the domain of an analytic function in the usual sense. Thus C is false, because see what is given in C in our question. In C we have the domain of an analytic function can not be open, need not be open. So no, this is not correct. It has to be open. And the last, if ux and vxy are real differentiable functions, then fz equals to this is also differentiable. This is not true. Okay, so see here what I have written. If uxy and vxy are only differentiable but do not satisfy Cauchy-Riemann equation, so there is an additional condition that they should satisfy this Cauchy-Riemann equation, then only we can say